Hey everyone, so in this lesson we're going to focus on the Pythagorean Theorem and its converse. So we have three objectives. The first objective is going to be to use the Pythagorean Theorem to solve for missing sides. Then we're going to use the converse to identify if a triangle is right. And if it's not right, then we're going to use the inequality theorems to classify the triangles as acute or obtuse triangles. So let's go ahead and let's review the Pythagorean Theorem. So recall that the formula for the Pythagorean Theorem is a squared plus b squared equals c squared. Now remember that the Pythagorean Theorem only works when you have a right triangle, and the values don't necessarily matter except for the hypotenuse. Right? Whatever the hypotenuse is, and we can identify the hypotenuse as the side opposite the right angle, the hypotenuse is always going to be the c value, no matter what. And then the a and the b can be either one. So let's look at an example using the Pythagorean Theorem. So I know that I'm going to have to use the Pythagorean Theorem whenever I have two sides of a right triangle and I'm looking for a third side. So in example number 1, I know that I have a right triangle, so we can see the right angle right there. And I know that I have two sides of this right triangle. So let's go ahead and use the Pythagorean Theorem. So we know it's going to be a squared plus b squared equals c squared. Now the only value that matters is going to be the hypotenuse. The hypotenuse is always going to be the c value. So let's go ahead and let's plug it in. So we've got 6 squared plus 15 squared equals, the c is just x. Now remember, the a and the b values don't really matter. The 6 and the 15, I could have rewritten it the other way and I still would have gotten this exact same answers. So now we can go ahead and simplify this all out. So 6 squared, we know that's going to give us 36. 15 squared, I know that's going to be 225. And that's going to equal to x squared. So I'm going to go ahead and add these two up. So I've got 225 plus 36. This is going to give me 261. And then I need to solve for x, right? So I'm going to square root each side to get x by itself. And then I'm going to look to simplify the square root of 261. So we're just going to see what can divide into 261. Let's see, can it be divided by 3? Yes, it can. So this is going to be 3 times 87. Let's see, 87 looks prime to me. Let's see if it can be divided by 3, and it can. So this is going to be the same thing as 3 times 29. And 29 is a prime number. Nothing else can go into 29. So we have a pair of 3's, 29. So my final answer here is going to be x is going to equal to 3 and then square root of 29. Alright, let's go ahead and look at the second example. So for the second example, I notice I have a right angle and I have two sides of this triangle. So let's go ahead and write down our Pythagorean theorem. So I know that we're going to have a squared plus b squared equals to c squared. The only value that matters is the hypotenuse, right? The one opposite the right angle. So there's my hypotenuse, so that's got to be 11. So I know that I'm going to plug 11 into my c value. And the a and the b don't really matter, so let's just go x, called ax, so x squared plus 9 squared. We're going to go ahead and simplify this out. So then this is going to become x squared, 9 squared we know is 81, 11 squared we know is 121. Let's solve for x by subtracting 81 from each side. And that is going to give me, let's bring the x squared down a little bit. So I'm going to have x squared is equal to, so 40. And let's square root this and simplify out. So this is the same thing as 4 times 10, which will be equal to 2 radical 10. And there we go. Whenever you learn about the Pythagorean theorem, it's always good to look at what are known as the Pythagorean triples. Whoops. So Pythagorean triples are going to be a set of three values. So we have three values there, three values there, three values there. That when you plug them into the Pythagorean theorem, they are going to equal. They are going to be equal. So for instance, 3 squared plus 4 squared will always equal to 5 squared. Right? And we can test this out. This is 9 plus 16 equals 25. 9 plus 16 is in fact 25, so that works out. Same thing would be true with the 5, 12, and 13. But the interesting thing about Pythagorean triples is that if you were to multiply these values by some constant number, right? So let's say it took 3, multiplied it by 2, take the 4, multiplied it by 2, and take the 5 and multiplied it by 2, you would get these values, right? 3 times 2 is 6, 4 times 2 is 8, and 5 times 2 is 10. So not only will the 3, 4, 5 work, but a multiple of that set of numbers will also work. So 6 squared plus 8 squared will equal 10 squared. So let's check it out. We know that 6 squared is 36. We know that 8 squared is 64. And we know that 10 squared is 100. 36 plus 64 is equal to 100. So it's always good to be able to identify these problems or to identify these Pythagorean triples, because that way if you do recognize one, you don't need to solve for the remaining side. You can just use the pattern. But if not, you can just use the on this slide we're going to look at the converse of the Pythagorean theorem. Now on the last slide we were given that the triangle was a right triangle. In this case, we don't know if it's going to be a right triangle or not. So instead, we're going to look at the three values, and we're going to apply the Pythagorean theorem, and if it is equal to c squared, so just like how it is here, so if it is equal to c squared, then we can say that it is a right triangle. So compare that to the Pythagorean theorem, right? The Pythagorean theorem says if it's a right triangle, you could use the formula. So how are we going to use that? So we're going to use this in a couple ways. Let me go ahead and label the three sides of my triangle, just like I did there. Now, if the Pythagorean theorem is true, then we know it's a right triangle. But what if it's not equal to c squared, right? What if the Pythagorean theorem does not work? So let's say that, well, we would have two instances in which it would not work, right? The first instance would be that the c value could be too big. Right, so if we look at this example here, let's just say the c value is too big, right? So I'm going to take my c value, and it is too big. So now what has to happen is now this side A right here is going to have to move. It's going to have to stretch out a little bit in order to reach it. So that's going to give us what's called an obtuse angle here. And it is going to give us an obtuse triangle. So that's why we say here, if the c squared is too big, that's going to give us an obtuse triangle. Let's look at what would happen if the c value was too small. So let's look at this example here, and let's say my c value was too small. So my c value was too small. So I have my c value, and it starts here, and let me redraw that, and it's too short. So now what has to happen is my side A right here now has to create a smaller angle in order to reach that side C. So now we get a smaller angle. We get what's called an acute angle, right? So if my c squared value is smaller than a squared plus b squared, and that's going to give me an acute triangle. So here are let's look at two examples for the converse of the Pythagorean theorem. So our goal here is going to determine whether the given side lengths create an acute, a right, or an obtuse triangle. So we don't know what type of triangle this is, so we're going to apply the Pythagorean theorem. We know that the biggest side has to be the hypotenuse. So this is going to be 15 squared plus 36 squared, and that's going to equal to, well, we don't know if it's going to equal to 39 squared, so we're going to test it and see if it does. We're going to multiply this out. 15 squared, I know is going to give me 225. 36 squared, I know is going to give me 1,296. And then 39 squared will give me 1521, so 1,521. Let's go ahead and add these two up. So 225 plus 1296, I know that's going to give me 1,521. So since these two values are the same, by the converse, we can say that the triangle is right. Right? We know that it is a right triangle. Let's look at the next example. So if you look at this example right here, now we have 16, 18, and 26. So I've got 16 squared plus 18 squared is going to equal to 26 squared. So let's go ahead and evaluate those squares. We know that this is going to be 256. We know that 18 squared is going to be 324. And then we know that 26 squared is going to be 676. Let's add these two up. And I get 580. So what's happening here is your C value is greater than your A squared plus your B squared. So if your C value is too big, remember so remember, right, if your C value is too big, this other angle is going to have to stretch out a little bit more, giving you an obtuse. So this is going to give you an obtuse triangle. So the triangle is obtuse. And there we go.